Hello and welcome to Pioneers Technologies Limited. My name is Mukala Wasiu. In this video, I'll be talking about the fundamentals of Python as one of the prominent programming languages. Python is an object-oriented programming language, and it's a language of choice in the field of AI, and is one of the best programming languages you can imagine in today's tech world. So knowing it is going to put you in a very convenient lead position to dabble into different programming languages because it is a fully object-oriented programming language. So to create a Python project, you need to download an IDE. This is my own IDE of choice for Python. It is PyCharm. So I need you to go to Google, download the IDE, configure it, and let's run the project. So let's go to a new project. We click project. So when we get there, then we can give our project a name. Let's give it Python fundamentals. So when we give it Python fundamentals, you can see we are not in a virtual environment. A virtual environment is like what keeps your code to be able to be recognized by the compiler and also to link it with the backend and to do a lot of functionalities that come with the Python programming language. So the virtual environment is one of the key requirements to run a basic Python code. So I'm going to choose a virtual environment. Then you see we are running Python 3.11, and after that I'll click create. Once I click create, my Python project will be created. I'll wait a minute for it to be created. Once created, you'll see this interactive learning box. If you need to learn more about Python or PyCharm, you can click next, but I'm going to close it. So this is the environment for running Python. Basically, a Python programming language or a Python file will run on some skeleton files, and you can see that at the lower bottom of this particular page, you see that this configuration is ongoing, and also you'll see that this is a basic Python file. This particular part of it can be said to be the opening part of it, and this is the closing part of it. So all these are comments. A comment in Python is always started with a hashtag symbol. So we call it hash symbol. You can take it away, it doesn't affect the code. So if I take this away, it doesn't affect the code. I also take the one at the top away, it doesn't affect the code, so that the code can be readable. So I'll take every one of the hash symbol away. So when I do that, there is a opening and closing tag, as I said earlier. What this means is that I'm running the main Python file. This is the main Python file. So it is saying that if this is true, then I'm going to run this particular part of the program. You can see print underscore I PyCharm. So this is what is going to be printed if this condition is true. That is, if the name that I'm running here is the same thing as the main method. So that is the main script. If it is true, this will be printed and this will be concatenated with it. I'm going to talk about concatenation later. That is going to be joined with it. So meaning that print I is a function that is going to be printed. What will it print? It's going to print PyCharm, but this I here will be joined to PyCharm to give it I PyCharm, because the name that we started with in the opening tag is the same name as the one that is in our print statement. So if I run this, you'll see that Python will start to compile, because Python is a compiled programming language. See, it says I PyCharm. So if I take this away now, if I take this away and I put the main method there, that I want Python to run the main method, then I take everything here away. Then I say, let me take everything away first. I'll remove the F because it means formatted. but I'm not printing any formatted string. I just want to print welcome to Python. So with this, I'm now going to start my main method. I will not specify any name now because I'm not interested in printing any special name. What I'm going to do now, I'm going to just leave this content of the bracket empty. Then I'll delete this. Then this will now be my main method, def main. You can see. Then I can now run the code. When I run it, you'll see I have welcome to Python because this is what I'm now interested in printing out. So mind you, you have to be careful about your indentation. Python takes indentation very seriously. This main method is this particular beginning of this script and this closing of the script. You can see that they are on the same straight line. So you need to take note of that because Python is really very concerned about indentation. So whatever you want to do within your Python file will now be done within the main method, which is the opening and closing tags. So here, let me declare but let me tell you something before I go. The least indentation you can give your Python script is a single space. That is the least. Some programmers use 4. It depends on choice. So here now, let me give you a very brief, let me call this variable p, and I'm going to say this p is going to have a value of 1. So if I say p is 1 and I want to print p, all I'm going to do is just put p inside that bracket because this print statement is used to print anything we want to print. If I run it, so you will see that it's going to show me that p is 1 because p has been represented as 1. So whenever I call p, 1 will be printed. So that is how Python runs. And if I want to print the type of p, I will just put the type method. There's something we call type. This type shows that what kind of variable is p. So if I run p, what is it going to tell me? It's going to tell me that p is actually a string. So that shows that anything that is in form of a word is taken as a string in Python. So if I take p this time around to not be a string, to be something that looks like a tuple, I'm going to tell you about what a tuple is later. Let's say 1, 2, 3, 4, 5, 6. You can see all the numbers are the contents of the p variable, and they are separated by a comma. So whenever you are declaring any variable, you have to separate it with a comma. So let's print p and see what happens. What does it tell us? It says that it is a tuple. You can see any variable that is contained, any variable that contains letters or numbers inside a bracket separated by a comma is called a tuple. So it is a tuple, and if I say that p is, let's say p is 1, and I declare another variable, let's say y is 3. If I want to print p plus y, I'll just say print p plus y, and you will see that we are expecting 4 as a value. So that is how it works. So I can also store this operation inside a variable called sum. I just say sum is equal to p plus y, p plus y. If I say p plus y, then this time around I'm not going to say p plus y again in the print statement. I'm going to print the sum because the sum has been the p plus y has been represented by sum. So that is how it works. Now if I want to now print sum, this operation p plus y is what is going to now be represented as the sum variable. So we need to take note of that. Capital letter P is here, that's why it is indenting it as red. So if I have to change to small letter p, the red line goes away because it is now declared properly. So if I run that, you see that the sum will be printed as 4 for me. So that's how it is. And you can also have a variable, call it a name. You can say name, the variable name. Let's call it Pinas. That is the name of the channel. So if I say I want to print sum, and at the same time I want to print name, meaning that I want to print sum together with name. So if I run that, the two variables are going to be printed. Because P is no more declared, then I have to remove P. Okay, let me declare P so that we have it in the code. P is, let's say, 4 this time around. So if P is 4 and name is Pinus, then we want to put the two variables together side by side. Meaning that if you want to print a variable, it is possible to print it side by side with another variable. So I have sum as 7, then the other variable name is appearing. And if I want to print an additional explanatory statement, I can put that inside a double quote. I'll say the sum is, then I'll say this. So when I do that, I'll put a comma to separate the variables from the statement that I've just put there. So if I put that, then I can run, say the sum is 7, then Pinus. So that is how you can print variables, and that is why you can operate on variables. Mind you, variables can also be letters, they can be anything. I can declare fruit here, say fruit, but fruit, I can put that inside a square bracket, because whenever you are declaring an array, this is called an array. An array always starts with a square bracket and ends with the closing square bracket. I can say fruit, I can say pineapple, then I'll put a comma at the end of every double quote because each of them has to take its own double quote. I'll say orange, then I can say bananas, So these are fruits. So I may decide to also print the fruit alongside the ones that are here. I say fruit. Since I've declared it, it's going to be printed and be taken as a variable. So let's run that. You see that I have those fruits there. So this is how we declare variables. And you can also declare a variable to be a true or false statement, because if something is not true, Python is going to return false for you. I can say that if 5 is greater than 4, then I should tell Python that print hello. Just print hello. Print hello. So I just say that print hello. So if this is true, then Python is going to go ahead and tell me hello, because I actually instructed it. It will take this one as true. Since it is true, then it will go and do this. So that's how it works. Let's see. It says hello because this is actually true. So if I want to do something else, I say else print no way. So else print no way. If I run it, it says hello. What if I say 5 is less than 4? Is that true? How does it say? It says no way. That is not true. So that is how you can use the if and else to declare a condition if it is true or not. And mind you, you can do a lot of booleans in Python. I can ask questions in boolean. Booleans are true or false statements. I can say print this for me, 5 greater than 4. 5 greater than 4. What does Python say in this aspect? Python says true. That is true. Python is right. Then if I say that print this condition, that I say 3 less than 8. And I can also say that Python should print this if it is true. If 5 exactly equal to 5, double equal to means exactly equal to. We use it for comparison. And I can say print is 5 exactly equal to 6. So Python is going to tell me if the conditions are true or not. Let's run it. Python says true, 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 then false. The last one is not true because 5 is not exactly equal to 6. That is how Python does its own. So we need to know these basics. They are so fundamental in the knowledge of Python. I can have a list here. I can have a list variable. I'll call it my list. Then I can put a list of numbers. Let's say 3, 4, 5, 6, 7, 8, 9, like that. If I do that, if I want to print my lists, I'll just say print. Remember, you have to call the name of the variable that you have declared earlier. If I say print my lists, then I run it, Python is going to give me that, oh, this is my list. Remember, this is not a tuple. This is not a tuple. So I can ask for the type of these lists. You can see that it's not a tuple. I can say type, meaning that I'm going to put type inside. I'm going to wrap everything inside what we call type. So what is it? It is a list, not a tuple. Can you see that? So that is how Python works. All these are so important that we know them. Then we can have types. Python also has different types of variables. So if I declare a variable, for example, as 3, I make A to be 3, I make B to be, let's say, 4, let's say C is 5, then let's say D is 4.5. Let's take E to be E. Let's say E is 3.80. Let's just take it like that. Let's say F is equal to 7.99. Let's say X is equal to 3J. Because Python can also take this kind of variable. And let's take Y to be equal to, let me just take away this. Let's say Y is equal to 4.21J. Let's say 4.21J. Then we can tell Python to tell us what type of variables are all this. So we say print the type of A for us. Tell us the type of variable that A is. Then I'll tell Python, let me make a copy here. I'll tell Python that after you tell me that, tell me the type of B as well. Tell me what variable C also belongs. Then I'll say, tell me the type of D. Then tell me the type of E. So when I do that, then I can move on to F. Then I can move on to X and Y. X and Y. This one is missing. The one is missing. One bracket is missing. Then I can say what is type of X and Y. So this is how Python is going to give us the logic. Let's see what kind of variables they are. I'll click the run button. Then I'll raise this up. You see that? It tells us that A is an integer, which is right. B is also an integer. If you look up here, you see that B is an integer, which is 4. C is also an. Let's go up. You see, A, B, C are integers. Then what is D? D is a float, meaning that any number that is a decimal is a float. So you can see E is a float, D is a float, and F is a float. Now, when it gets to X and Y, it says they are complex numbers. You can see complex numbers, the idea of complex numbers is incorporated into Python, which means that you can have complex numbers as you have in engineering mathematics if you want to have it. So Python is really on ground for machine learning, artificial intelligence, and complex engineering calculations. So that is how we learn, and that's why we declare the type of variables that we have in Python. Let me take all of them away so that I can use this code to do something else. Now, I'm going to tell you how you can make some operations in Python, how you can perform some operations. Let's say 63, X is 33, let's say Y is 7. Then I want to print, remember your print statement is to give you the result. I want to print X multiplied by Y. What does that give me? Let's run it. What does it say? It says 441. You see that? That is to say that asterisk means multiplication. What if I want to divide? What happens? What do I have? I have 9.0 because 63 divided by 7 is 9 point. 63 divided by 7 is 9.0. So that is how Python does. What if I want to subtract? Of course, this is going to give me a negative and that a negative number. You see, it says 56. Wow, sorry, that shouldn't be a negative number because x is greater than y. What if I interchange it? Y minus x, I'll expect a negative number. So let's run it. See, I have minus 56. So that's how it works. Now, I can say what is the absolute value of a number because Python also has the concept of absolute value, which we call modulus in our mathematics. If I say A is equal to ABS, means absolute value, then I'll say minus 56. If I ask Python to tell me the absolute value of that variable A, then what does it say? You are expecting that to remove the negative value and tell us that it is what? 56. So that it will not be a coincidence, let me make this one to be 567, like that, 56677. So that let's see. You see that it removes the negative value. So there is this idea of negative values in Python, which is the absolute value. We need to take cognizance of that because it's really important. Now, let's see how Python works with indices, that is index positions of variables. I'll take this away. So let me text this. I want to put a text, and this text is going to be called I everyone. So this is the name of the text with another space. So I told you that Python is so important, and Python takes the space very, very important. So let's just print the text. We're going to print the text. If we ask for the text, what does Python say? Python says I everyone. Now let us now print the text according to different positions. We call them index positions. If I print 0, what does Python give me? Python just says H because H is at position 0. What if I ask for the third position? What does Python give me? Python gives me E. So this is the third position letter. So 0, 1, the space is 2. The space is 2 because Python takes space as a character. So the third one is E. So that is how we declare index positions whenever we are dealing with Python. And we can do it in the negative manner as well. If I put print, then I do -4. Then if I ask Python to give me what is in -4 position, it gives me, oh sorry, I was printing -4. Let me print the text and ask for the index position of -4. That is what I intended. So let me run that again. You see, it's giving me O because it's coming from the back. It's coming from behind. It takes this space that is before the closing punctuation, before the closing quotation. Yes, before the closing quotation mark. This is a space. It is a character. So it takes the space and it counts 4 from the back. 1, 2, 3, 4. O. Letter O is the one in the 4th position. That is how Python does. Now let us take another, let's call another text. Let's call this one text 2. Text 2. Then let's call this one, let's say Pythonista, Python lovers. Python lovers. Let's say Pythonistas, Python lovers. So let's say that. Then we'll now say that we want to have the index position of each of them. Let's say print the position of texts 2, then give me this position of 2.5. Let's see what happens in this case. Let's run it. You see, it gives us error because it tells us that no, Python does not use decimal points to indicate index positions. That's why you see that there is a squiggly, there's a yellow squiggly line under. So if I say 5, that one is recognized. If I run that, what does it give me? It says n because it starts from 0, 1, 2, 3, 4, 5. N is the 5th position letter. So that is how Python works. And I can ask for the length of the whole of this text. I'll just say print the length. The length means the number of characters there. So len is length. I'll now enclose that inside a bracket so that will be the length. So let's ask for that, for the length. It says 29. If we count all these letters together with the spaces in between, that is together with the spaces in between, that is the empty spaces, it is actually 29. So that's how Python works in terms of variables. Mind you, there is this idea of typecasting in Python. We call it type conversion. When you are able to convert from one variable type to the other, it is called type conversion. So for example, now this is a text which is called "I everyone." This is another text too, which is called "Pythonistas are Python lovers." So these are text variables, but at times you have a variable in form of a decimal, that is in form of a float. For example, s is equal to 4.55. Then I now say that, let me take away this, then let me take this away as well. X is 4.55. then I now say x is going to be equal to, I want to convert this 4.55 to an integer, so I'll put int outside and I'll now put x inside. Then when I do that, I can now come and print x as a variable. So you see that normally this is a float. As we said earlier, that decimals are floating numbers. So this time around, x has been typecast to an integer. So it will not bring 4.55 again to give us an integer. Let's see. Okay, Python is compiling. Okay, that's 4. It gives us 4. You see that? That to tell us that this floating number has been converted into an integer because we have typecast it. So that we'll call typecasting or type conversion. So we can also do that for a float. I can take this one to be 4 because that's an integer. Then I will now convert it to a float. So that is how we do typecasting in Python. You can see that float is also a keyword. That's why it is indented as purple. So if I run that, 4 will be converted to a float, which is a decimal. So it is from integer to decimal. So that is how it works. And this typecasting is a very, very important aspect, particularly when you are dealing with the backend, when you need to take the data in form of APIs and you need to convert them to the right form so that you don't have errors. So they are so important. I also need to point out that you need to be conversant of float, and also you need to be conversant of strings. Any variable that you put inside a double quote is actually going to be taken as a string. Even if the variable is a decimal, it's going to be taken as a string. So this is a string. Let me declare another variable as sum, but in this case, I'm going to convert everything to float. Then what will I convert to float? That variable x. Then I will now add it to another float, which is 6.5. So I can now come and say that, oh, I want to now print my sum here. You can see that I've converted that to float. So both are floats. This one is a string. This one is a string. X is a string. It has been converted to a float here. Now it is now being added to another float. So we can now come and print out the result. So what the result going to be is a floating number, 10.8. So it's so important that we know how to typecast variables. As I said earlier, it's going to help us a lot. Let's take another variable as true. Any variable that is either true or false is called a Boolean. Let's take another one as false. Now, if I now print A, and and at the same time I print B, what does it tell me? Let's see what it brings. It says true and false. So that's what we call booleans, true or false variables. Mind you, I can also have a variable in form of a, then I'll say a is equal to 2 asterisk 3. This means 2 raised to the power of 3, which is 2 times 2 times 2, which is going to be 8. So if I want to print a now as a variable, I'm expecting to have 8 as the answer. So that is how we take exponential, and we need to know how to take exponential. There's something we also call remainder. If I say I want to take a remainder of any variable, it is actually denoted by the percentage sign. So the remainder of 5, when it is divided by 2, is going to be 1 because it's going to remain 1. So if I want to take the remainder, I'm going to have 1 because I'll have two whole number 1 over 2, and that 1 is the remainder. It's different from when I have the ordinary division sign. As I said earlier, this one is going to give me the right result, which is 2.5, 2.5. So that is how it works. We need to know how to work with operators because these are the fundamental aspects of Python. We need to also know what is called the floor division. The floor division is when we have double division sign, the double division symbol. I'm going to put the division symbol here, 5, then I'll say double 2. This one means floor. Floor means I'm taking the division and I'm running it down to the quotient of its numerical operands to the nearest whole number. So if I run 5 over 2 to the nearest whole number, I'm going to have 2 because I'm going to have 2 as the operand. So that is how it works. Now let's see what we call the operator precedence. In Python, operator precedence is when you are talking about which one comes first from addition, multiplication, subtraction, then all this, as we know in BODMAS, is that division comes first, multiplication follows, addition, then subtraction. So addition will come first, giving us 13 minus 7, that will be 6. So we are expecting 6 from this. So I can come here and come and print a, because that's the name of the variable. So when I run this code, I'm expecting 6. You can see, and I have 6. So that is how it works. So we need to know how operators are preceded over one another. If I declare a variable as a as well, let me give you another one. If I declare a variable as a and I say a is equal to 3, if I say a plus plus, meaning I've incremented a by 1. See, a plus plus means that I've incremented a by 1. But the way to do it is by saying a plus, then I'll say equals, a plus equals 1. So with this, I have incremented a by 1. If I now want to print a, what am I going to have? Let's see what I'm going to have. If I want to print a now, what am I going to have? I have 4. You see that? A was 3, incremented by 1, that's 3 plus 1, then I have 4 printed out. So that is how we increment. And if I want to decrement by 1 as well, I'll just put minus there. And if I run that, I'm going to have 2 because a was 3. Then if I remove 1 from it, it becomes 2. And if I want to multiply it by that, I'll just say 2. So this will be 3 multiplied by 2, which should give us 6. So that is how we do incrementation. We call it increment and decrement in Python as we have it in other programming languages like Java. So I can also have a factor in which I'm going to print these together. I'm going to declare the variables side by side. A over a comma b means I can say 0 comma 1. In this case, 0 is corresponding to a and 1 is corresponding to b. So that's, I can also declare x comma y as, let me just say x is 0, then I will say y is 1. You can see? So that means x is a string, y is also a string. So if I now ask x is less than y, for example, if I put that and I say a is less than b, you see that? So these are different variables and they are representing different values. So I can put my if statement here. I'll say if in that case A is less than B, and at the same time, you see the and, this and is a keyword in Python used to link two conditions together, and at the same time X is less than Y, then I have to stop my if statement with a colon. Then if that is true, then print this, print yes. You see that? So I will now come and close it up. I say else, then you can print no. That means that condition is not true. You can see that the if and else are on the same straight line because they form the same block of code. So let's run that. What do we have? No, because they are not the same. The condition does not meet. X, A is less than B. This one is correct, but X is not less than Y because X is 0, Y is 1. So this one does not hold. The second condition does not hold because this and symbol requires both the left hand side and the right hand side of the if statement to be true. Because one is not true, then else comes in as what is printed out in the console. So that is how Python tests a lot of conditions. So that is how we need to know the way Python works. And Python is a very strong programming language, as I said earlier in the opening statement. And this is going to put us in a very good position to learn other programming languages. So that is that for this section of the Python codes. I will release another video very soon. I would like you to subscribe to my channel. I'm going to give you more of fundamentals because this is going to help you a lot by making you strong in a programming language. And I'm going to simplify the code more and more to make your sojourn and your journey in the Python world to be so easy, so that you find Python as one of the simplest programming languages that you can ever learn. Thank you. I'll look forward to you subscribing to the channel, liking the video and sharing the video, and also watch out for the next episode of this series. I'm going to release another episode in the next few days. Thank you, and thank you so much for coming, and thank you for subscribing. I'll see you in the next video. Thank you.